Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Logarithmic Formula Memorization Basics. Concept number 5, the log base b of b. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a new paradigm. I want to include everyone who needs a boost in Algebra 2, and if I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to order and purchase your healthy dose of Algebra 2 beyond the Logarithmic Formula Memorization Basics series, okay? You have lots of peers, classmates, and colleagues who could really benefit from this cram session as well. So be sure to spread the word and tell them to inbox me at memedicine@gmail.com so that they too can order the complete cram session. The concept of cramming often gets a negative connotation, but what people are actually thinking is we're hurrying, and that's not the case. Hurrying is a result of fear and can consequently be destructive to your learning process. We're cramming here, and there's a huge difference. Hurrying is jam-packing tons and tons of unorganized information into your mental DNA over a tiny amount of elapsed time, whereas cramming is taking quantum leaps in your understanding in an organized way in what seems to be an instant, okay? So let's delve into the concept of log base b of b. Logarithmic formula. Solve the log base b of b. I'll give you a moment to think and definitely press pause if you need to. All right, so hopefully by now you were able to press pause and come up with an answer, and if not, that's completely fine. Before mentioning the solution or the exponent that yields a power or a result of the base b, okay, we first need to understand the general format for an exponential function, because exponential functions are the basis for the logarithmic function, okay? The general format for an exponential function is y is equivalent to base b raised to the x, where b is positive, so it's not going to be negative, and it's not equal to 1, okay? This can be the case, but just not for a logarithmic function, because things get a bit hairy when you introduce this, okay? And here you see on our coordinate plane a graph of what an exponential function would look like, okay? And don't confuse this format for a polynomial function, because in a polynomial function, the formatting is actually in reverse, where the base is our independent variable x, and the exponent would be the constant, okay? All right, so once again, for an exponential function, the base is a constant, the exponent is our independent variable, and the power or result y is our dependent variable. Sometimes people have faux pas and they call exponents the powers. This is actually a misnomer. Yeah, they're not the same thing. Let's say, for example, the exponent was assigned a value of 2. Then you could say that the result, or y, is the second power of the base b, because our exponent is 2. Okay, so don't confuse the two. Also, don't think, actually, did I go over that already? Yeah, so that's that. I think I'm having a memory lapse here, but just in case I didn't tell you, this is not the format for a polynomial function. where the base would be the independent variable and the exponent would be a constant, such as x to the second power. So it's not a polynomial function, okay? All right, now let's get into the logarithmic concept. A logarithmic function is the inverse of the corresponding exponential function with the same base. Okay, so let me show you how we would represent a logarithmic function. It's going to look like this. Y is equivalent to the log base b of x. And basically with this function, you're trying to figure out what exponent you had to raise this base b to in order to yield the result or power of x. Notice I'm saying things in reverse because this is actually the inverse of your exponential function. But just in case you're not getting the drift, let me demonstrate how this logarithmic function would look if you were to express it in exponential notation. So this is equivalent to x is equivalent to b raised to the y. Again, remember that algebraically, in order to yield the inverse function of your starting function, you switch the independent and dependent variables, or simply put, you switch the x and y values, hence our exponential version of our logarithmic function. I know this whole thing is getting a little circuitous, but just bear with me. So for this or any inverse function, constants remain constants, okay? So the constant in your exponential function is also going to be a constant in your logarithmic function, or the exponential expression of your logarithmic function, okay? But x is now the power, or the result. So this is the result here. And y becomes the exponent. So this y is actually representing an exponent and not a power, okay? These are synonymous. All right, on a coordinate plane, the graph of the logarithmic function is basically the reflection of the corresponding exponential function over the line y equals x. Okay, and so here goes an example of our shape for our logarithmic functions, the basic shape, okay? Alrighty then. And in the case of log base b of b, we can re-express this as y equals the log base b of b, okay? And an equivalent exponential version of this is going to be b, which is our result or power, equals b, our base, raised to the y being the exponent in the logarithm scenario, okay? All right, and again, this is exponential notation of our logarithmic function. And the reason why we're doing it like this is because we're trying to figure out what y is, okay? And the only exponent that would yield the base, the original base as a result, is 1. Because anything raised to the first power is going to equal itself, okay? And so that means y is equivalent to 1. And this makes sense because we can double check our graph and see that for a logarithmic function, when y is equivalent to 1, our x value is approximately 2.718. And this makes sense because this logarithm graph is actually a graph of the natural logarithm, or Euler's number, when the base is e, the natural number, okay? So yeah, things kind of match up and check. All right? Yeah, thanks for tuning in. And what's the big idea with all this? Well, if you know how to manipulate logarithmic expressions, you can simplify that such an expression within the grand scheme of maybe a bigger problem. Okay, that's why it's important to recognize that this whole thing right here, y is equivalent to 1, because you can go from this to 1, which is really convenient. And as you can see, intellectual comprehension of the log base b of b concept was not difficult at all. And after the short amount of time it takes to complete the entire Cram session, you'll be prepared to answer a battery of questions about any Algebra 2 concept. So inbox me at memedicine@gmail.com to order and purchase the complete Cram session. Thanks for tuning in and have a great day.